Awesome. Thank you very much for having me. It has been shared, my name is Abubakar Siddiq Ango. I am a developer evangelism program manager at GitLab. It's an awesome experience to be to when I got the chance to speak at this event because I'm part of the community. I led Google developer groups back in Nigeria, Bauchi, Nigeria. I'm originally from Nigeria. So when the opportunity presented itself, I was like, wow, I definitely need to be a part of this event and contribute my knowledge. So first introductions, like she shared, I'm Abubakar Siddiq Ango. I do developer evangelism program management at GitLab. Basically, what it entails is we have a developer evangelist team, and what they do is basically developer relations that speak about GitLab itself, the cloud native technologies, and so on. So my role is to make sure that the team gets everything they need to work as efficiently as possible and also gets the right results, the right results from the contents they are creating. Like I shared, I'm originally from Nigeria, but I'm currently based in the Netherlands, The Hague to be specific. So if you can follow me on Twitter, my Twitter handle is Sarki247, SARKI247. So straight to the talk. Now, technology has evolved so much lately that there are lots of ways to do things. There are lots of ways to create solutions to problems. And we are not short of new problems coming up every day. Long were the days when software engineering was just basically you writing some code, putting it on a floppy disk, insert the floppy disk on the drive A of your Windows system, and run your code. It has now evolved to a system whereby we have cloud services, cloud providers all around. You no longer need to build a data center or to buy racks of servers to be able to deploy your application online. With services like Amazon Web Services, with GCP, Azure, and quite a lot of other ones that are coming up, it is much more easier for you, a startup or an individual, to be able to create a solution to a problem, deploy it, and scale it online without having to make some heavy investment into infrastructure. And with this comes the need for you to be able to manage those infrastructure as efficiently as possible, which is where infrastructure as code comes in. That's what IAC means on this image. Now, with infrastructure as code, previously, if you want to build your devices in the previous days, or I think a lot of people still do it now, where they go to the market or to the tech shop, buy RAM, buy processors, buy the motherboard, fix up everything. Gamers and people that need high-end systems still do it to this date. Buy some specific type of GPUs that they want, or tune their system to some specific configuration so that they can get as much throughput from it as possible. Now, with infrastructure as code, it has become easier with cloud providers that instead of you to go into your console, maybe AWS console or the GCP console, to say, oh, I need this number of instances, I want this particular type of RAM, I need this storage, I need this and that. You can define them within a document, within a file. Oh, I'm going to be using this cloud provider. These are the type of operating system image I need, maybe an Ubuntu or a Red Hat or a CentOS, whichever one, based on your requirements. These are the amount of instances I want to create. Maybe you are trying to scale your infrastructure and you want to host a number of servers behind a load balancer so that your applications can scale easily. You define all of them, then use tools like either we have Terraform, we have Ansible, we have Puppet, we have quite a number of them in the market. And they are often classified into orchestration tools, which are the ones that create your resources. and configuration management tools, which are the ones that make sure that everything is installed perfectly on your servers. So with that, you can then deploy, you can run the tool. For example, with Terraform, you can do something like Terraform plan to see, okay, all these things that I've defined that I want to deploy on my infrastructure, are they the right thing? Are there mistakes there? Then Terraform apply. Once you do Terraform apply, it goes to your cloud provider through their API to then say, oh, provision this number of servers with this image, provision this number of storage on S3. Once you are done, create a load balancer, put it in front of it, take all the instances, put them in a VPC, and create a DNS record and point the load balancer to the DNS record. Everything is done automatically. You don't have to do it yourself. Now, one of the benefits of this is you are able to keep a state of how your infrastructure is and how it's evolving. And you are keeping a history of how your infrastructure is changing so that when things go wrong, you can always revert back automatically. Now, this is not just for virtual machines. We now have service providers that are providing metal services, metal in the sense that physical devices. Oh, you want this and that. We now have infrastructure as code that enables you to be able to use those also. Now, but it goes beyond you just running some of these commands, be it Terraform or Ansible or Puppet or whichever one on your system. What if you work in a team? What if you work in an organization whereby there are processes in place? We all know that DevOps is beyond just some technologies or tools that you use to manage your development lifecycle. It's a culture, people, process, technology, which come together to create a way in which your company or your team or your organization or you as an individual get the solution you've created for a problem from your system straight to production. Now, and one of the ways you can do that is to use merge requests, which is what is MRs on the image. If you are using GitHub, it's called pull request. And in the concept of GitLab, merge request isn't just you submitting a change, asking someone to review and demerge it. It evolves to a situation whereby you can have reviewers on your code, you can have approvers on your code. People can make comments. You can run CI/CD, continuous integration on the changes you've made within your MR, and as new changes are being done, you can see how the changes are evolving. Now, you can even test out your application to a point with an MR. So when MRs merge with, when you use MR for infrastructure as code, it allows you, let's say within an organization, you have a developer, you have an SRE, you have a finance team, you have the CEO. The developer can say, oh, I need this amount of Kubernetes cluster, and it should have GPUs. It should have 1 terabyte of RAM. That's quite a lot. 1 terabyte of RAM, etc. And he pushes. Now, once he pushes, it will not be deployed automatically. Your CI will go through what he has pushed to check, okay, what exactly is this guy or this person requesting? Then, if you're using Terraform, it does Terraform plan and gives a detailed plan of, okay, these are the infrastructure we currently have. These are the new changes this person is introducing, and this is how they will be deployed. Now, if I recall correctly, I think Terraform even allows you to see the cost the changes were introduced. That's show you in dollar amount. It does this by they already understand how the AWS pricing and everything works. So it gives you, these resources that you are pushing, this is the amount it will cost and so on. So, and you can use what we call code owners. I think it's also on GitHub, where you can define within your repository, if certain changes are introduced to your code, so and so people should be notified to review it. Your code owners become reviewers. Now, you can have the manager of the person or maybe the SRE as a code owner of the code repository, And he is pinged, oh, please go through this, review it, and see whether everything is right. And once that is done, you can have an extra approver. You can even select that, okay, everybody must approve before this is deployed. Now, maybe the finance team can then come in and say, oh, wow, this thing you are requesting will cost us $10,000 more, or a lot much more money than we've budgeted. So please review. Now, until everything is accepted and everything is fine, before a merge is finally done, and that is when, if you're using Terraform, Terraform apply is done, which is where continuous delivery comes in, or continuous deployment, and whatever it is you've done is deployed. Now, if it's in the context of Kubernetes, you will have created your Kubernetes manifest file, push it, MR runs to confirm that everything is fine, or if you're using Helm to create your Helm package to deploy to Kubernetes, it runs the necessary tests that needs to be done, displays it, asks for feedback from everyone. People can even comment within or before the actual deployment is done. Now, all these three together, infrastructure as code, merge request, CI/CD, are part of what forms the idea, the philosophy around GitOps. Now, but let's go into how does the GitOps working group, the CNCF has a working group called GitOps, where a committee has sat and has reviewed a lot of use cases around companies to now define what are the basic principles that forms what we can call GitOps. Now, if you are just looking at it, you see, okay, GitOps. Okay, probably it means you documenting the way your infrastructure is and putting it on Git. Yeah, one can easily decipher that from the name, but it goes beyond that. The first thing is your systems, which can be your application with your infrastructure and so on, must be declarative in the sense that there is a detailed line-by-line declaration of this is how I want my application to be, which is often called the desired state. I want my application to be this way. I want my infrastructure to be this way. Then versions means you are using Git. As new changes are being introduced, you can go back to see what changes were introduced, how were they introduced, who introduced them. And maybe through the Git commit, you can know, okay, this is the reason why they were introduced. And it should be immutable in the sense that what you've defined in your desired state shouldn't just change from, it shouldn't be different from what is actually running on your production or in your main environment. It should be that any new change you are creating should be reflective of what is the production. Now, one of the ways that GitOps is different is sometimes things happen in your production environment, and the only way you will know is if you have some form of logs or some form of notification in place that will then send you a Slack message or through some errors that, oh, something has gone wrong. But with GitOps, there should be a mechanism where as soon as something goes wrong, a pod fails or some infrastructure has crashed or anything has happened or storage got corrupted, there should be automatic reconciliation in the sense that your actual state, like the way Kubernetes works, your actual state that is running within your production should be able to synchronize with your desired state that you've defined that, okay, this is how I want things to be, but this is how it's running. Okay, there's a bit of difference between them. Let me make sure everything is in sync. And this happens automatically. That's why we have operations through reconciliation to make sure everything is the same across board. Now, often there are two ways to achieve this, which is when you're doing CI/CD, we have the push, which almost everyone is familiar with if you've been using version control with CI/CD. You write your application, you push it to your application repository, it triggers a CI build, and once the build is done, if your application builds images, you push it to the image registry, and any updates you've made to your infrastructure is kept in your environment repository for a record, then deployment is done. So everything goes from left to right. You are pushing it to your production environment. It's one way. So in this case, you don't require, this is agentless in the sense that you don't require anything installed in your cluster or in your production environment for deployment to happen. It simply pushes. One of the disadvantages, this is like the easiest one, but one of the disadvantages of this is you have to make available some form of credentials to your CI/CD environment so that it will be aware of where it needs to push or deploy to. And this is one of the disadvantages because when you are in regulated environments like fintech or banking or some other critical environment, they have a lot of stringent regulations that need to be followed, which most often include security. And they don't usually like making credentials available to external components. So that is why for GitOps, pool deployment is often used. Now, in this case, your application has been deployed to your repository. It triggers a build to do all the necessary tests, all the necessary integration that are required for your application to be built. Then, and often, most times, the application and the environment configuration or your infrastructure definition are usually in the same repository. So it builds your application, pushes it to an image registry, creates so that you can use it as a container later. Then the definition of how your environment will be is pushed to your environment repository. That means you have two things: where your application is kept and where your environment repository is kept. Now, this time there's an operator in your environment, most especially if you're using Kubernetes. That operator will then constantly be observing your image registration and environment to see, are there new changes? Are there new things that I need to persist within my environment to deploy? Now, you will see that the environment is cordoned off this time because it might be in a secure environment or it might be behind a firewall. You can't reach it, but it can communicate outside. That is why you see the operator is observing outside both the image registry and the environment repository. Now, and as soon as it sees that something has changed in your image and environment repository, it deploys it. Now, from your deployment also, it also observes deployment to see whether has there been any changes to the actual state of how the environment is. If there is, it will go to the image registry. Kai, something has changed here in the deployment. Let me check the environment repository to see if there are new changes, or let me pull the desired state of how my deployment is supposed to be and update it. So in scenarios where things fail, the operator can automatically fix issues that are happening because it has access to the environment repository and it will just deploy. Maybe in cases where something is wrong with your cluster, but it has access to the manifest that has been stored in your environment repository, it pulls it and applies it automatically. Now, with this, you agree with me that GitOps fosters collaboration in the sense that since most often your application and your infrastructure definition are in the same repository, developers and SRE and other people are able to work together and define how everything would work before they are deployed. Now, if you are using DevOps platforms like GitLab, collaboration starts from you creating an issue. Oh, we need to fix this. We need to do this. We need to do that. And by the time you've created you've pushed your code on how your application would work, the infrastructure team sees what you've pushed. They now understand the requirements that is needed for it to run within the infrastructure. And that way, everybody works hand in hand to make sure that your systems, your solution works perfectly, which leads to everyone being aware of what is going on. That's distributed learning. Now, a major part of GitOps and why a lot of companies are adopting it is because of the security. First, For you to use the push deployment, you need to probably create RBAC authentication or get your certificate and other things and put it in your CI/CD environment so that the CI/CD environment can authenticate with your cluster to push. That is already an attack vector which can make your infrastructure to be vulnerable because credentials to it is somewhere, and who knows who has access to it. Or if something happens to the CI/CD environment, they get hacked or something, it will definitely affect your systems. So, but with GitOps using pool deployments, no credentials needs to be set up. The only thing is that your environment needs to have access to the image repository to pull things down and deploy. Now, the next thing is, how do you, some of the use cases that you use for GitOps, like we've seen infrastructure automation and application deployment, your whole infrastructure has been defined to be autonomous. It just works. As soon as you've defined how your infrastructure should be and you've pushed it to the image and environment repository, the operator ensures that infrastructure is always up to date and it's always deployed. And your applications, so whenever there are changes to your environment, maybe new pods, if you're using Kubernetes, new pods have been deployed or new nodes have been created, the operator knows where to pull your application from. So everything is automatic. Now, drift management. Now, this is often in situations where your actual state, which is what is in your production environment, all of a sudden has changed. Or something has gone wrong. What is running is different from what you've defined. And one of the ways GitOps ensures that everything stays in sync is to make sure that anytime there's a drift, or maybe for some reason someone goes to your infrastructure and makes some changes through the console, or logs into the Kubernetes cluster and messes up some things, maybe delete some pods or delete some nodes, or something else happens, GitOps ensures that everything stays intact, goes back to how you've defined your desired state, pulls the changes and applies them automatically. So this is to ensure that it is what you've defined and what everyone has access to, everyone knows within your organization is what is running. This allows organization to not have cases where your infrastructure can go haywire or you no longer understand what is happening within your infrastructure until maybe you see your AWS bill at the end of the month. You're like, why do we have this and why do we have that? But with GitOps, or if you're using infrastructure as code, you know exactly what is running in your infrastructure. No surprises. Now, policy enforcement, because in a lot of regulated environment, there are a lot of regulations and a lot of policies that they need to follow. For example, DevSecOps need to be in place for you to make sure that whatever it is that is being deployed, maybe you're a banking platform and you need to ensure that you have PCI DSS regulation, which most fintech and banks need to have to make sure that their systems are secure and no form of attack needs to be in place. Maybe your organization has a policy on the type of containers that can be used within your infrastructure. Instead of just going to Docker Hub and just pulling any image, you want to make sure that the right images are being used. So you can implement DevSecOps policies so that during your continuous integration or your testing, everything needs to be followed. Licenses of the dependencies that you are using, it needs to be checked. Maybe your organization doesn't want to use any open source or Apache licenses or MIT licenses. They can implement all those from CI stage to make sure that everything that is going out is secure. Now, other things are like secret detection. Yeah, mistakes happen. Sometimes you can commit secrets. Maybe you forgot to add it to gitignore or something. There should be policies in place whereby as soon as secrets are detected, it should either rotate the secrets, that's change it, or notify through a security dashboard that something has gone wrong. You definitely need to fix this before it is pushed and the whole infrastructure is exposed. Now, also because your environment is in a closed place, it's easier for you to make sure that all forms of security implementation, firewall rules can be implemented, because the CI is not trying to get in. Instead, it's pulling or anything it needs. So that way, you are able to make sure a lot of security implementations are in place. Now, I've already discussed about security scanning when I was talking about policy enforcement. So that means for you to implement things like secret detection, license scanning, container scanning, dependency scanning, to make sure that everything you are using in software engineering, we stand on the shoulders of giants. We reuse things that other people have already created that are out there that have been vetted. But in certain situations, things can always go wrong, or there are some bugs that have been introduced that might create a problem for you. So ensuring that you scan all these things, or in situations where you can connect to things like the OWASP CVE repository, where new bugs that are being discovered, your CI system can easily scan against it and ensure that your environment is secure. Like governance and compliance, I've already mentioned a bit about this, where you need to comply to a lot of regulations implemented either by regulatory authorities or data privacy rules by the government, etc. GitOps allows you, because first, you are more secure because of the way you are using pool deployment. Now, also in your CI/CD, you need to make sure you use continuous security testing to follow all the governance and compliance requirements. Then GitOps is beyond Kubernetes. I think a lot of people see GitOps as, okay, it's mainly about managing Kubernetes manifest file and deploying them to the Kubernetes cluster. But we've seen that a lot of people don't use Kubernetes. There are a lot of regulated environments who are often slow to adopt new technologies. So instead, they are using other tools like, okay, they have Terraform to the infrastructure deployment. They have Ansible to do configuration management. They have a lot of other things that they've created, or they are using Puppet, which uses an agent to pull things. So GitOps is more about the principles, the philosophy around how your infrastructure runs, and not necessarily restricting you to using Kubernetes. So that's the end of my talk. These are some of the resources you can look at and you can review to learn more about GitOps, some of the use cases around, and also know how to participate in the community. So I'll be sharing this slide with the organizers later so that you all can have access to it. So if there is any question, let me check here in the chat. Are there any questions? I don't think there's any question. So if there's any question, I'm available to answer questions. Am I still in time? Yeah.